Hi everyone. We are finally going to talk about the whole story of the derivative. So we figured out what a derivative at a point is. If we pick an x value and we calculate the derivative at that x value, what we found is the slope of the tangent line to the original function at that x value. And what we want to build up to is a little bit more complete picture of what the derivative is, not just a point-by-point thing. So we have a preview activity, which is to calculate the derivative at 4 different x values for this function f of x equals 4x minus x squared. So if you want to pause and work through at least a couple of these at the top, in fact, I think you'll have to work through all of them to be able to answer the bottom questions, kind of get us on track with what's going to happen next. Okay, so assuming you've paused, I'm going to do a cheater way. I don't know if this is good or not. Let me know if you don't like it, if you'd prefer to have me talk all the way through these. But for a preview exercise, I'm just going to put this up. Here's all of my work, so I'll talk a little through the first one. So we're just using the limit definition, which means we'll need a limit as h goes to 0. So this first one, this is f prime of 0. So we would need the limit as h approaches 0 of f of 0 plus h, right? There's that f of a plus h minus f of a, and RA is 0 for this first one. So 0 plus h is just h, no reason to write out any extra mess there. Which means when we plug that in, we get 4h minus h squared. So this is the f of h part. And then f of 0 is 4 times 0 minus 0, which is 0. And then we can walk through our usual sort of simplification, and we should get 4. And then the next three are all really similar, and I hope you notice that as you go. The work is really, really similar. We are changing this number that we're working with. The a changes every time, but otherwise we plug a plus h into the function. We get this first chunk. We plug a into the function. We should just get a numerical value. And then they all have the same simplification. Distribute a 4, FOIL out the middle term, distribute the negative sign through the middle term. And then when you collect, you should have no constants left, only h's, at which point you can factor an h out and cancel it. And then the very last step is once you cancel that h, you can let h go to 0, and you should be able to get an answer. So these three are all really similar. So pause and check those out if you need to check anything, but hopefully you've gotten this pattern going, 4, 2, 0, negative 2. And part B is asking us to check out that pattern. There we go. And based on our pattern that we spot, try and predict what the values of f prime of 4 and f prime of 5 will be. So this was f prime of 0, 1, 2, 3, and then we want 4, 5. So what I've noticed here, and I hope you notice as well, is that this goes 4, 2, 0, negative 2. This is decreasing by 2. So minus 2, minus 2, minus 2, which would lead me to predict that this is a negative 4 and this is a negative 6. Okay. So we've got our guesses, and now we're supposed to go even one step further and say, based on this pattern that we're spotting, and we've just extended out even a couple more. Oh, sorry, let me move down for you. There, we can see most of it. Can we write down a formula for the function? So basically, if the outputs of a function have some really nice pattern, we should be able to think of an equation that represents that. That's what algebra is all about, recognizing those patterns and representing them symbolically. So we've recognized part of our pattern. This thing, this f prime, decreases by 2 every time our x value increases by 1. That is spot on how you would describe a linear function, right? So if your output decreases by 2 every time your input increases by 1, then you've got a slope of negative 2. And if this is really a linear pattern, the other piece of information we need is a y-intercept. And we, in fact, have that up here at the top. We know that when we input a 0, f prime outputs a 4. So we can describe this this pattern that we're seeing as whatever a we pick, f prime of that a is negative 2a plus 4. Okay, so what this is all leading up to is recognizing that our derivative exists at a bunch of different x values. For every x value you plug in, it tries to tell you the slope of a tangent line. And sometimes there isn't a slope, but generally we can talk about the slope of a tangent line. And that is in itself a function. It inputs x values, outputs slopes. So it's definitely not the same as the function that we started with. It was inputting x values, outputting y values. But it is a function. It has input-output pairs. And that's what we want to work our way up to. When you talk about the derivative of a function, you're talking about a whole new function that inputs the exact same x values and outputs y values, or I'm sorry, output slopes after all that talking. Output slopes. Okay, so that's our preview. Thanks for watching.